Hi! In previous lessons, we have demonstrated the relationship between magnetic and electric fields and the force they exert on charges in a conductor. In this lesson, we shall look at one of the applications of this effect, and this is in the operation of electric motors. At the end of this lesson, you should be able to explain or define what an electric motor is, identify some of the basic components, and state some devices that use electric motors. An electric motor is an electrical device that is able to convert electrical energy to mechanical energy by turning a current carrying coil in a magnetic field. This is similar to the process we described in our lesson on the magnetic force on a loop. We explained how passing current through a wire loop placed in a perpendicular manner in a magnetic field will produce a turning effect. This turning effect can be used to turn other devices or components. Instead of a loop, electric motors have a coil or set of coils placed between the poles of a magnet. An electric motor can be made in two ways. It can be made in such a way that the magnet is fixed and the coil is made to rotate, or the coil is fixed and the magnet is made to rotate. Let us look at an electric motor where the magnets are fixed and the coils are made to turn. This large area over here is called the stator. The stator is made up of a core that has two or more magnets attached to it. Inside the stator is the rotor that is allowed to rotate. The rotor has a set of wires wound around it in a number of turns that make coils. These coils are usually made from copper wires. The rotor sits on a shaft. When the rotor turns, it also turns the shaft. It is the shaft that then turns any other component that is attached to the electric motor. For example, the blades on your fan are connected to a shaft. Attached to the electric motor are the brushes. The brushes are terminals that allow electricity to enter the electric motor to the coils. Connected to the shaft are small pieces of copper that rotate with the shaft and rotor. These are called commutators. The commutators are set in such a way that when the rotor turns half a circle, the coil makes contact with the commutators. Because the commutators are connected to the brushes, they provide current to the coils at every half turn. When the rotor completes half a circle, the commutator reverses the flow of current supplied to the coils. This half-turn current reversal ensures the coils get a continuous supply of current to keep turning the shaft. Electric motors are used in almost all electric devices. Like we said earlier, the blades of your electric fans are placed on the shaft of a rotor. So when you connect the plugs to the electric socket and switch it on, you're only supplying current to the brushes in an electric motor in the fan. These brushes pass the current to the commutators, which then supply the current to the wire or coils in the rotor. This creates a force that turns the rotor, and the shaft and the blades turn. Other devices that use electric motors include blenders, microwave ovens, vacuum cleaners, mixers, drilling machines, and even grinding machines. So keep learning, guys.